Okay, let's have a quick look at this question 16. A particle P has a mass of m kg and is released from rest. Okay, um, released from rest down the line of a steepest slope of a rough plane inclined at angle theta to the horizontal, where theta is less than 45 degrees. Coefficient of friction between the particle and the plane is 0.5. The plane is now inclined at angle 2 theta to the horizontal, and another particle Q of mass m is released down. The coefficient of friction is 0.5. Okay, the time taken for P to travel travel 1 meter is the same as the time taken for Q to travel 2 meters. Okay, right, so let me just have a quick think of this. Right, okay, so let's have a quick go. So first of all, let's do the P particle. This horizontal, excuse me, that's inclined at theta, and there's the particle P, and it come down here with mass m, so that's mg. Okay, and that's being projected down, so P of mass is released from rest down, so it's coming down this way, it's released from rest. A rough, right, so that's rough. So what we got here, we got down here, comes along here, that's going to be theta, that's going to be coming down this way with mg sine theta, and that is reaction, and that's opposing reaction, so coming down here is going to be mg cos theta. Okay, so we've got all we need from there. So that has friction, so as that's coming released from rest from there, friction is going to be going in that direction, opposing it. Okay, so I think we've got most things there, so let's look at the next thing. That's going to be with particle P. Now particle Q, now that's on a slight steeper, that's 2 theta. So particle P, the plane is now inclined at 2 theta, and another particle Q, mass m, is released down. So from here, this has a mass of m. Now that's a capital N. I don't know whether that's supposed to be the same, but we just leave that be at the moment. So that's going to be mg. So if that goes like this, making that slope 2 theta parallel, so coming down, it's going to be mg sine theta. That's again going to be the reaction, Rn, and that's going to be coming down this way, going to be mg cos. Now I should have wrote 2 theta, my bad, because that angle is 2 theta. Okay, now it's telling you that the time it takes for P to travel 1 is the same time it takes Q to travel 2. So Q is traveling twice as fast as P. So whatever P's acceleration is, which let's call it A1, okay, and let's say the acceleration of Q is A2, we know that A2 is traveling twice as fast as A1, okay, because it's covering double the distance in the same time. So that's what the acceleration is. So we got that. Okay, so we can say that. Right. Okay, I think I'm ready to go now. I think we're okay. We can try to work out what the acceleration is. So what do we have on this one so far? We've got that's coming down, so that's going to be, because I'm just going to double check it. Coefficient friction is, oh, we know that, sorry, before we start. Coefficient friction between the plane and, right, it's going to be 0.5, so mu in each case is going to be 0.5. I'm just going to say, because it's active, it's rolling down, friction is going to be mu times Rn, and so for P the friction is going to be 0.5 times Rn, which is going to be mg cos theta, and for Q it's going to be, friction is going to be 0.5 capital mg, just going to put that up a bit, cos 2 theta. So that's this one. Okay, so now we got that. Let's start. So what we got here, we got mg coming down, so that's going to be sine theta minus the friction which is going against it, so the friction at that is going to be 0.5 mg cos theta, and that's going to be mass, which is mg, sorry, it shouldn't be mg, it should be just m times acceleration. Okay, so that's small m times acceleration. So that's for P, and that's, I'm going to call the acceleration a1. And for Q, we're going to do the similar thing. We've got, this is coming down with a capital mg sine 2 theta. What's going against it is this friction on Q, which is going to be 0.5 capital mg cos 2 theta, and that's going to equal capital M times the acceleration, which I'm going to call a2. Okay, so what we could do here, let's go use a different pen here. When we're working at the acceleration, we first of all could cancel the m's, and well, we know g is going to be, is it g? I'm just double checking mass times acceleration. Okay, we've got g there, so let's just leave the g there. So we've got g sine theta minus 0.5 g cos theta is going to equal the acceleration 1. That's the acceleration of P. And for Q, if we got capital M everywhere, so let's cancel that M, and that M. So we've got G sine 2 theta minus 0.5 G cos 2 theta equals A2. Now we know this fact that this is twice as that. Okay, so now we can do some, we can change this, change that, so we could bring that in and double that. So what we could say, I'm just going to use a different color so we can link this all up. Actually, that looks nice. So let's look at that. So that A2 is going to be G sine 2 theta minus 0.5 G cos 2 theta is going to equal double that. So I'm going to get 2 lots of that. So that's going to equal 2 G sine theta minus, now if you double that, that would make double half is 1, so that would be minus G cos theta. So I've literally times that, all that by 2. Now I'm just looking, keeping an eye on this, what I need. So if we can now, that's, we've got G's everywhere, So what I could do is just cancel the g's out. Okay, and let's just write this down in a simpler version. We got sine 2 theta minus 0.5 cos 2 theta is equal to 2 sine theta minus cos theta. Now what you could do here, we got sine 2 theta, cos 2 theta. We want all thetas. Now you should know that from double angles, sine 2 theta is the same as 2 sine theta cos theta, and cos 2 theta. Now I want everything in terms of coses, so I'm just saying cos 2 theta is the same as, yes Marlon, go away please, it's going to be 2 cos squared theta minus 1. Okay, so if I sub those in here, that will give me 2 sine theta cos theta, and if I do 0.5 times that, I'm gonna get half of that, so that's gonna be just minus cos squared theta, and I'm gonna get half of that, which is going to be my 2 negatives, so that's going to be a plus 0.5. So literally replace cos 2 theta and with that, and times that by half, and times that by times that by minus half, and times that by minus half to give me that, equals 2 sine theta minus cos theta. Okay, so if I now bring everything to one side and leave the 0.5 there, so I'm gonna just make a box here so don't confuse people here. So now I'm gonna leave that there, bring that to the other side. So I've got 0.5 I'm gonna leave on the left hand side. So if I bring that to the other side, I'm going to get 2 sine theta minus 2 sine theta cos theta, and then I'm going to get this is a minus cos theta, and I'm going to take that to the side, which is going to give me a plus cos squared theta. Now if I factorize this one, take the sine 2 theta out, I'll get 1 minus cos theta, that's going to be 0.5, and if I factorize this and take a cos theta out, in fact a minus cos theta out, I'm going to get 1 minus cos theta. Now I've got a minus cos theta here, minus 1 cos theta here, so I'm going to get 0.5 equals, so that's the common factor in both of them, so I'm going to get 1 minus cos theta, which is being times by this, which is a 2 cos theta, 2 sine theta, that is minus cos theta. Now that, if you look at this, I've got it the other way around, but that's fine, they're the same, because if I times that by a minus, they will switch over and they will switch over, so that is exactly the same as that. I'm just gonna quickly show you that if I switch those over, so that if I make that 1 minus cos theta, so if I times that times this bracket by -1 and times this bracket by -1, so that will switch those around, and that will switch those around. Okay, minus minus makes a plus, so it makes no effect to that, and that is exactly what we got here. So that is true, we've got that. So sorry, I ran out of space, so I had to squeeze that in here. Hope that makes sense. Okay, thank you.